In the case that the oxyacids have the same number of oxygen, how could we tell which one is more acidic than the other? Okay, let's draw out the conjugate base first. All right. Now you can see it right here. All the negative charge right here, all the three negative charges are on the same atom, same oxygen. Okay, so similar element. So which means that this oxygen have the same electronegativity, same size. So those are those don't matter, and the number of oxygen are the same. Well, nothing really like a tiebreaker here. So we have to look at the electronegativity of atoms nearby. Okay, so we talk about chlorine, bromine, iodine right here. And you usually remember first organic chemistry, need rubber shot. The chlorine has the highest electronegativity, right? Followed by bromine and iodine. Okay, and this electronegativity of atom nearby can stabilize the negative charge on oxygen. Okay, so the relative acidity goes from like this. So hypochlorous acid have the most acidic, followed by hypobromous and hypoiodous. Okay, this effect is called inductive effect. All right. Again, you learn this much more in organic chemistry, but I'll just tell you just a little bit about it. All right. So, what is the inductive effect? What does it do, and what is it? To do that, let me explain in a little bit how for our communication. So, I'm going to convert like a full structure to a bond-like structure, so it's easier to explain. Okay. You'll see it later. All right, so in a full structure, I have two carbon 1, carbon 2. I'm going to convert that to just a bond-like structure. Carbon 1 right there, carbon 2 right there. All right, acidic acid down here, same thing. Carbon 1, carbon 2. So carbon 1 and carbon 2. So this is a line we call bond-like structure. All right, inductive effect. So some of you are Harry Potter fan, maybe. All right, if you're not, total, that's fine. All right. So in Harry Potter, we have the what's it called? The mentor or soul sucker, whatever, that's what it's called. Okay, so this guy look like a ghost and will suck happiness out of you and you die, basically. All right, so inductive effect just like this, the mentor. That's how it works. Okay, look right here. So we have ethanol on the left side, so 2 carbon 1, carbon 2. On the right side we have trifluoroethanol. Okay, and you guys know fluorine, the most electronegative atoms in a periodic table. And so it works like this. The negative charge right now is on oxygen. Okay? So the negative charge is on oxygen. So I'm, by the way, so I just drew the conjugate base of trifluoroethanol right here. So it looks like that. Excuse me. Okay, so what's going on here? The negative charge has electron density, so right there. The fluorine right here will suck electron density out of oxygen. Okay, basically stabilize the charge. So instead of the electron density stay on just oxygen atom, it's spread out a little bit further to the fluorine right here. Okay, so which means that the conjugate base of trifluoroethanol is more stable than just an ethanol, no fluorine. Helping stabilizing the charge. Right, and the relative acidity, much higher acidity here, almost 3,000 times. All right, come down here, same thing. We have acetic acid, chloroacetic acid, dichloro, and trichloroacetic acid. Look at the pKa, go lower, 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 and lower. Right, that's because the electron density on oxygen right here is stabilized by 3 chlorine. Got pulled like that? Oh, hold on. By 3 chlorine. Okay, so the more chlorine, the more stabilized the negative charge, and the stronger the acid. All right. Okay, so that's the electronegativity. That's how it works. All right.